Hey, peace and blessings, everybody. It's your brother Asare back with yet another one. Um, peace to the true and living. Who's the true and living? If you're watching this, you are the true and living, man. Appreciate you for tuning in. Nice to meet you. Um, Now today we're going to continue on our series on the ether. On the last two installments of this, of this the series we've been doing on the ether and everything like that, we talked about kind of like what the ether was. Now, the ether is an ancient concept. Ancient people was dealing with the ether as a concept from a metaphysical perspective. Since really, um, I know we can nail it down to so-called Greek mythology, like we talked about in the previous videos, pretty much Phoenician, Ethiopian mythology, as it were. When we get into that, we get into stories of um, the ether and chaos and all that, the primordial gods of that particular so-called mythology or whatever case may be. But we want to nail it down. It's a lot of subjectivity associated with the ether in some aspects or whatever case may be. Um, it's associated in the Vedic I don't know, metaphysics sort of so to speak, as akasha. You see what I'm saying? So it has a few different variants across different cultures. We want to nail it. We in this series, the way we've been dealing with it, we've been nailing it. We've been nailing it down to 19th century electrical theory, because electrical theory is the stuff that has patents. Electrical theory, it produces the stuff that you can go to Walmart and buy. Electrical theory ties into what we talked about in previous videos in regards to biometric devices, AI medical monitoring and stuff like that, or whatever case may be. It ties into fields, because we talked about the difference between particles as opposed to fields. Um, we talked about the two different types of physics that we were seeing when we talk about 19th century electrical theory. You have people like John Keeley, Nikola Tesla, Oliver Heaviside, certain people that don't believe in the electron. They don't deal with the electron. They don't deal with these quarks, gluons, muons, and all these hypothetical subatomic particles, photons, and all that stuff like that. They're dealing with their electrical theory, and their understanding is based off of the ether or whatever case may be. So you would have something like light or whatever case may be from a general relativity, quantum mechanics perspective or whatever case may be. You would have photons. That's a hypothetical particle that carries light or whatever case may be, and it has a particular speed, which is the speed of light or whatever case may be, that nothing can go faster than the speed of light according to that understanding or whatever case may be. As far as, let's say, like somebody like Tesla or Keeler or whatever case may be, from an etheric perspective, where you're dealing more with fields and stuff like that. Light is not necessarily a particle. It's a perturbation in the ether. It's a disturbance in the force, Yoda. It's a disturbance in the ether. You feel me? So yeah, so see how that sounds like I'm talking about Star Wars or something like that. It's funny how they put things in movies or whatever. So when somebody like myself would come here and try to talk about it, you be like, oh man, he just got that from Star Wars and stuff like that. He has a tinfoil hat on or whatever the case may be. I got a copper pyramid, but I ain't got no tinfoil hat on, Bill. So like I said, um you'll get into those notions of the ether and everything like that. Um you see two different styles of this. You'll see prior to J.J. Thomson inventing the electron and quantum mechanics being the accepted theory, and then you'll see um, where the ether is the accepted theory and everything like that. Now we're gonna contrast some stuff or whatever. We're gonna talk about the CERN. Now we want to talk about it from like the two different perspectives. I want to contrast some stuff. I'm kind of making a contrast between two different types of jargon that you would have to navigate through if you're trying to understand some of this stuff. Um, you see what I'm saying? Um, in a lot of the stuff that's probably written or whatever case may be, it's gonna be written in a way where it's written from a perspective of general relativity and quantum mechanics, the Einstein's theories and stuff like that. It's going to be written from that perspective or whatever. Um, a contrast to that would be um, etheric physics or whatever, more akin to what John Keely or Nikola Tesla was talking about, or whatever case may be. Um, and we're gonna contrast that. Now, we're gonna talk about CERN, but I want to before we even get into CERN, because with CERN, right? With the significance of this conversation with CERN, right? We're talking about a particle accelerator, a large hadron collider. Hadrons are these subatomic particles that Tesla says don't exist. So if the hadron collider is banging particles against each other or whatever case may be, according to this guy, he said that these particles that's being banged against each other don't exist. So what are they really doing? So from his perspective, so that's kind of what we're going to examine. Okay, we examining two different kind of levels of jargon and two different perspectives of looking at this stuff like that. So before we even get into any of that, because we talking about hadron colliders and particle accelerators, but so what are you talking about all this crazy stuff like that? I got a microwave refrigerator in my house. What are we talking about? Okay, so let's talk about so what does that look like? uh we all watch television broadcasts. This is an example of some akin to a broadcast. It works in a very similar way. So television broadcast, that's something we can all agree exists in actual reality, right? So let's see what the AI says the explanation for how a TV broadcast works from a perspective of mainstream physics, how we would, describe that, how we, how we talk about that versus Tesla's more ether-based physics, right? So let's kind of get into that. Okay, so I basically asked the AI as far how does a television broadcast work? How does it work, the sending of and receiving of the signal? So, okay, content and I'm gonna kind of run through this the abridged version so this doesn't take all day, but so we can just get a general idea. Microphones and okay, content creation, the studio, cameras and microphones. The journey begins in the television studio or location where specialized cameras capture images and microphones capture sound. These devices convert light and sound waves into electrical signals. Um, let's see here. All right, transmitter. Talking about the broadcast tower, the transmitter, the modulator carried wave, the modulator carrier wave, now carrying the television program's information is fed into a powerful transmitter. The transmitter amplifies this signal significantly. Okay, reception, antenna. In your home, an antenna, like a traditional rooftop antenna or an indoor antenna, captures this electromagnetic wave. The radio waves induce a weak electrical current in the antenna, mirroring the original broadcast signal. Okay, let's see here. Okay, so it's talking about the sending and receiving of a wave from one antenna to another. Okay, so that's how that sounds. Okay, so according to the AI, let me see here, Gemini AI. So this is that same thing from the perspective of Nikola Tesla and Eric Dollard. So this is the AI saying this. Okay, so uh let's see, Tesla, visionary and practical inventor, conceived a world wireless system that included broadcasting images long before practical television was widely developed. He would emphasize the following resonance. And so, before there was television, how we know it, Nikola Tesla was already talking about something like this. If I'm not mistaken, television was invented in the 1950s. Let me see here. Um, so so you're already talking about a world wireless system. You can read about Wardenclyffe, the Wardenclyffe Tower, and everything like that. But okay, so let's see what it says. Resonance and sympathetic vibrations. Okay, this is the same thing that John Keely was talking about. How we discussed in an earlier video. We're talking about John Keely and probably the person who's the most knowledgeable as far as John Keely and a lot of his work is probably Dale Pond. So John Keely and Dale Pond and stuff like that. This is what we were talking about in the previous video. Okay, so man, I saw you talking about sympathetic oscillation and all this stuff like that. You talking about morphogenic fields and all this stuff like that. So let's keep this pushing. We right now we're talking about television broadcasts. We already talked about how it's sending and receiving a signal. So let's see what he's talking about. Resonance and sympathetic vibrations. For Tesla, the key to transmitting any information, including images, wirelessly was through resonance, right? He believed that a television camera would convert light information into electrical variations, which would then be impressed upon a high frequency electrical oscillation. This oscillation would be broadcast not primarily as conventional Hertzian waves propagating through space as transverse electromagnetic waves. So remember, in the previous definition, we were talking about electromagnetic waves being sent and received. Okay, the oscillation would be broadcast not primarily as conventional Hertzian waves propagating through space as transverse electromagnetic waves, but as longitudinal waves or disturbances in the omnipresent ether, right? So basically, he would be operating on what would be perceived as a higher frequency. You see what I'm saying? Um, the receiving television set precisely tuned to the same resonant frequency would then sympathetically vibrate and pick up these subtle etheric impulses, right? Remember how we talking about how light would be a perturbation or a disturbance in the ether. You see what I'm saying? Similarly, he would be talking about a similar concept as far as this. And this is why in his model of things you can have faster than light travel, because you just get to a more subtler level of the ether or whatever case may be, and you can vibrate faster than, let's say, light travels or something of that nature. Ether as the medium. Tesla firmly believed in the existence of a pervasive, intelligent ether that filled all space. This ether was not empty space, but a dynamic medium capable of transmitting energy and information. Television images, from his point of view, would be conveyed through manipulation of this ether rather than just through radiating electromagnetic fields in a vacuum, right? He envisioned the broadcasting station acting more like a ether whistle or a tuned vibrator, all right? Electrical pressure and induction. He would likely explain the image transmission as a rapid variation in electrical pressure or dielectric stress within the ether, rather than solely as a flow of electrons, because remember, he don't believe in electrons. These variations, encoded with the visual information, would induce corresponding effects in the receiving apparatus, leading to the recreation of the image. All right. Let me see here. Global communication and energy transfer. Tesla ultimate vision extended beyond just isolating television broadcasts. He saw television as a part of a larger system for worldwide communication and even wireless power transfer. So he considered all this stuff pretty much the same, or to be transferred in a very similar fashion, or what have you. The same in a very similar way how John Keely kind of conceptualized it. Let's see here. Okay, so this is what it says, Eric Dollar's perspective, and this is the AI saying this. Eric Dollar is still alive. He actually has videos and stuff like that, so you can watch him saying it. But this is just for the sake of this conversation. Eric Dollar, a modern electrical engineer and researcher deeply influenced by Tesla's work, critiques mainstream electromagnetic theory, Maxwell's equations as commonly interpreted, and emphasizes the importance of dielectricity, magnetism, and the ether as fundamental forces. He would explain television broadcasting in terms of dielectric and magnetic fields. Dollard posits that electricity is fundamentally a phenomenon of ether in a state of dynamic polarization, dielectricity, and ether in motion, magnetism. Conventional electromagnetic waves are for him only one specific and often inefficient manifestation of these more fundamental forces. Longitudinal waves and true wireless. Dowlard asserts that true wireless transmission, as conceived by Tesla, primarily utilizes longitudinal electrical waves or dielectric waves that propagate through the ether. Unlike transverse electromagnetic waves, Hertzian waves, which he considers a retarded, unnatural form of energy transmission, longitudinal waves are characterized by oscillations parallel to the direction of propagation and can travel faster than the speed of light in certain conditions. Okay, the last little section, and then we'll get into CERN. Um, let's see, resonant networks. Similar to Tesla, Dollard emphasizes the crucial role of resonant networks at both the transmitter and receiver. The television signal encoded as variations in dielectric stress and magnetic flux will be impressed upon a powerful resonant electrical system, like a specialized Tesla coil magnifying transformer. The system would then launch these longitudinal disturbances into the ether. So this is how they kind of view this stuff, more so as disturbances in the ether when you get to a certain level. So, whereas regular um, general relativity and quantum mechanics deals with these smaller particles, subatomic particles, or whatever. Like you take an atom and then you break it up into different. It's the particles that compose the atom, or whatever, quarks and biops and all these little particles that they come up with, or whatever, hypothetical particles or whatever. They don't deal with all those hypothetical particles or whatever. All of that energy that's perceived as the particle is just a disturbance in the ether to them. Okay, so so as you can see, um, this is kind of like two different models or whatever case may be. Thus, um, even in the explanation to things that are not, mysterious or nothing like that, we find ourselves arriving at a different explanation for common things or whatever case may be when it comes to stuff. Simple as like broadcasting. You see what I'm saying? Broadcasting a a television show or something like that, sending and receiving of a signal or whatever case may be. One version of this stuff is talking about Hertzian waves or what have you, or what have you, or whatever, signals being sent and received from one location to another. Another one is talking about longitudinal waves and more so disturbances in the ether. Sounds a little bit more like Star Wars. Sounds like the stuff that we were talking about in previous videos when we talking about morphogenic fields and, what I'm saying, whole ethnic groups of people being able to store information across generations and stuff like that, not just learned information or whatever, but information from the field being the field storing trauma in it, in individual people. Oh, remember the videos where we were talking about the analytics of fighting and everything like that. Remember how I told you that the relationships between people or what have you, and the fluctuations thereof, kind of like how we talked about when we were talking about the experiential material, the fluctuations of of the ups and downs in the relationships between a group of people or two people or whatever the case may be, is very similar to the mediation of pressure or the changes in pressure across an electromagnetic field. It's kind of like that same thing that it kind of sounds a lot like that similar conversation or whatever case may be. So the point of kind of going back into the ether and stuff like that, because when we talk about fields, we leaning less on this Einstein general relativity stuff, and we're leaning more toward in the direction of what Tesla and Keeley were talking about as far as the sympathetic oscillation and stuff like that. You see what I'm saying? It sounded similar to the same stuff we was talking about in previous videos or whatever. Oh, how you feel about other people is a mirror. How you feel about yourself and all this stuff like that or whatever case may be. It's sounding similar to like how nature works. You see what I'm saying? How these how this version of field theory is kind of lining up or whatever case may be. So in that same vein, in that same mindset, you see what I'm saying? Um, what is a particle accelerator? Let's kind of get a little bit into this CERN stuff. What is a particle accelerator? Because we're gonna get into CERN in a minute, but we're gonna kind of walk into this real quick. So give me a sec. Okay. Okay, so we have okay, what this is www.energy.gov. So it says a particle accelerator. Particle accelerators are devices that speed up the particles that make up all matter in the universe and collide them together or into a target. This allows scientists to study those particles and the forces that shape them. Specifically, particle accelerators speed up charged particles. Okay, so that's the that's the definition of what a particle accelerator is. That's kind of what we talked about in the beginning of the video. We were talking about CERN and everything like that, and what they said that it does or whatever. But we just explored an iteration of quantum theory or an explanation for this stuff that does not involve particles. So, okay, so that kind of leads us to the question or whatever case maybe what's the Tesla version of that? And again, I'm not professing that this is the same thing. If I could reanimate Nikola Tesla and stand him up right here in front of me or whatever, and I interviewed him and asked him these same questions, I can't guarantee you 100% this is what he would say, but this is more in the direction of what he would probably say. Okay, so okay, so we're gonna get into this. Okay, let's see what CERN is. Okay, okay, so this is the Google AI. So we going into that. We always do the light lifting with the AI. You see what I'm saying? So what is the CERN Large Hadron Collider? So, the CERN Large Hadron Collider is the world's largest and most powerful particle accelerator. So, that thing that we just talked about, the largest and world's most powerful particle accelerator, it's a 27-kilometer ring of superconducting magnets located in CERN, a European particle physics laboratory in Switzerland. The Large Hadron Collider accelerates and collides beams of hadrons, these hypothetical particles. Um, Hypothetical particles. I got a hypothetical imaginary baseball. I'm about to throw it to you. Can you catch? Did you catch it? Okay, so that's kind of like what we talking about. So it's a hypothetical particle. So in which, in this alternate view of electrical theory, quantum theory, however you want to say it, they don't. Tesla didn't believe in hadron. He wouldn't have believed in hadrons. So that kind of seasons. We just kind of seasoning the pot here a little bit. Okay, so let's see here. The LHC accelerates and collides beams of hadrons like protons at nearly the speed of light to study fundamental particles and forces. Okay, here's a more detailed explanation of purpose. LHC's primary goal is to test theoretical predictions in particle physics, particularly those related to the standard model. How it works, it accelerates particles to extremely high energies and then collides them. These collisions create new particles, allowing scientists to study their properties and interactions. Okay, it's gonna tell you to discover the Higgs boson, and it's gonna go on from there or whatever. But that's basically that's not only the world's largest particle accelerator, that's the world's largest machine, if I'm not mistaken. You see what I'm saying? Um, so yeah, so that's what they say it does from that perspective. Just like how we looked at a television broadcast from that perspective and what they say it do. They say we sending and receiving. Tesla would have us believe it's more of a thing of sympathetic oscillation, similar to a lot of the other conversations that we've had prior to this. So here we go. Okay, the punchline of the entire video. Okay, so this is what we just talked about. Your particle accelerators are used in um, X-ray machines, MRIs, and all that stuff like that. Those are smaller versions of a particle accelerators. I think lasers, different things like that. Part are what particle accelerators are used for on a smaller scale. This is the mega scale as far as that's concerned. So hold on, let's see here. Okay, so Nikola Tesla's version of the universe was profoundly rooted. This is the AI. I'm going back into the AI. So I'm asking the AI what is and we're incorporating Eric Dollard's stuff, and understanding Nikola Tesla's perspective. Um, Based on that perspective of electrical theory, his understanding, what is a particle accelerator to him if there are no particles like that? You see what I'm saying? So, okay, so Nikola Tesla's version of the universe was profoundly rooted in the concept of the ether, a pervasive, invisible, and incompressible fluid-like medium that filled all space. From this perspective, matter itself was not composed of discrete fundamental particles like electrons, which he didn't believe in as separate entities, but rather arose from disturbances, stresses, or whirls within the ether. Eric Dollard's research deeply explores and expands upon Tesla's ether theory, emphasizing that what we perceive as electricity and magnetism are not flows of particles within wires, but rather phenomena of stress, strain, and motion within the ether surrounding the wires. Conductors in this view don't conduct electricity, but rather guide or reflect the etheric disturbances. So this is a different type of way of viewing it. Okay, so, given this ether based framework, how would Tesla, informed by Dollard's interpretations, describe the function of an atom smasher like the Large Hadron Collider? So that is the punchline of this entire video. Okay, Tesla's ether-based description of an atom smasher LHC. From Tesla's perspective, an atom smasher wouldn't be smashing fundamental indivisible particles because such particles in the modern sense wouldn't truly exist as independent entities. Instead, he would likely describe the LHC's function in terms of manipulating and interacting with the ether itself. Okay, creating extreme etheric disturbances. Okay, the LHC accelerates protons, which Tesla might consider to be highly organized, stable vortices or stress points in the ether. So, what they're calling protons, he wouldn't view it probably potentially as protons like that. It would be just stress points in the ether, um, to incredibly high velocities. Okay, so the LAC accelerates protons, which Tesla would consider to be highly organized, stable vortices or stress points in the ether to incredibly high velocities. This process, rather than accelerating discrete particles, would be seen as inducing immense kinetic energy within these etheric worlds. The powerful electromagnetic fields used to guide and accelerate these protons, quote unquote, would be understood as precisely controlled distortions and movements within the ether, compressing and energizing the etheric structure that constitutes the protons, so called colliding etheric vortices. When these highly energized quote unquote protons collide, it wouldn't be a collision of um, solid objects. Instead, it would be a catastrophic uh, interaction of intensely concentrated etheric vortices. These collisions would create extreme local pressures, strains, and shock waves within the ether, unraveling and reforming etheric structures. The debris observed after collisions, the various subatomic particles like quarks, gluons, and even the Higgs boson would not be seen as truly fundamental particles. Instead, they would be interpreted as transient etheric resonance patterns. The collision would momentarily disrupt the stable etheric patterns that form the so-called protons, causing the ether to momentarily form new unstable and rapidly decaying patterns or resonances. Damn, that could sound like the Mandela effect, don't it? Yes, it's just funny. Um, and when I say funny, I you gotta laugh to keep from beating your head against the wall with some of this stuff. But um, that sounds like some of the odd stuff that's been going on since they built that thing. Some of the stuff that we've been experiencing, as far as the weird occurrences. One of which being, the Mandela effect. These new particles. So you smashed two etheric vortices together destroying something and making something new. Let me see. Okay. Hold on. New. Okay, so these new particles would be temporary manifestations of etheric energy, akin to ripples or complex wave formations on the surface of a distributed pond. Yeah, because that was always I always assumed that basically you opening up portals and new dimensions and stuff like that. You breaking new thresholds and trying to open up new dimensions. It's like what everybody else says or whatever. It sounds from this perspective, it sounds like what everybody else is saying. You're opening up new dimensions and portals and all this, that, and the third or whatever. But it sounds that's it clear. It sounds a little bit clearly like that here versus if you tell me you're just smashing two particles together. You see what I'm saying? We discovered, whatever come out of that, the other imaginary particles we invented, they come out of that, and we can tell you what the universe is like. Versus this, it sounds like what we experiencing. You see what I'm saying? Okay, so uh, break down products of larger vortices. The protons themselves, quote unquote, being complex etheric structures would upon extreme impact break down into simpler, smaller, and less stable etheric worlds or oscillations. The quarks, so called, would be seen as constituent sub-vortices, and the gluons as the binding forces or etheric linkage between them. So all the particles or whatever case may be, or perceived particles or whatever case may be, are basically just disturbances in the ether, is what he's saying. Let's see here. Release of etheric energy. The immense energy concentrated in the high speed proton vortices would be released back into the general ether, often manifesting as these transient particles or as electromagnetic waves, which are themselves vibrations of the ether. The probing of the nature of the ether. Ultimately, from Tesla's perspective, the LHC would be an elaborate experiment designed to probe the fundamental nature of the ether by subjecting it to extreme conditions. Scientists would be indirectly observing how the ether responds, how its inherent stresses and motions manifest as what we perceive as matter and energy, and potentially discovering new, more transient forms of etheric organization. That sound like you might open a portal and bring something back. That's what it sounds like. But anyway, the goal wouldn't be to find elementary particles, but to understand the dynamics and properties of the underlying ether itself and how it gives rise to all observable phenomena. Let's see, from Tesla through Dollars lens would view the Large Hadron Collider not as a machine that smashes atoms into their constituent particles, but as a device that creates enormous localized disturbances within the universal ether, causing complex etheric structures to unravel and reform into transient, high energy etheric patterns, thereby revealing more about the dynamic nature of the ether. So you're basically destroying something and reforming it on a vibratory level, basically. Yeah. So okay, wow, that was kind of interesting. Um, so I would say that one of the takeaways from that, besides the obvious, what that sounds like and how that correlates with everything we think we've been experiencing or whatever, everything that people been talking about, they kind of been experiencing or whatever. Um, I ain't gonna put that like I always say, I ain't gonna put that sauce on it for you. I'm gonna let y'all put that sauce on it. Y'all heard kind of like how that sounds and kind of like how that lines up. Sounds like something out of a movie, don't it? But anyway, if versus innocently smashing two BBs together, you know what I'm saying? Um, all my science buffs, y'all, excuse me if I butchered any aspect of that. I mean, I was trying to get somewhere in the ballpark or direction. Like I said, if y'all got Eric Dollar's number on speed, how y'all call him up, ask him that same question or whatever. Or if he make a video about it or whatever, that's an interesting thing. But yeah, as we can see, when we look at a lot of different things and a lot of different phenomena and things or whatever case may be, as it's explained, through the lens of the mainstream, theory, relativity, or quantum theory, or whatever case may be. As we can see, when we filter it through a different lens and we kind of incorporate the etheric physics, or the theory of the ether, or we come to kind of, I don't know, different conclusions. And a lot of the things that we've been discussing that kind of border upon what people may view as metaphysical or whatever case may be, when we even start discussing things in this kind of lens of physics or whatever case may be, some of that stuff that sounds kind of tinfoil hattish, it don't really sound as tinfoil hattish because, you know, I think Tesla's a very um, good example as far as this is concerned because he has a lot of patents. So though the theory of some of this may sound tinfoil hattish to some people or whatever case may be, um, Tesla could actually build a machine based off of what he's talking about. So we can't really argue with that. So that's pretty much what I had with this one today. I just wanted to contrast, as we've been going into this whole thing about the ether or whatever case may be, I just wanted to actually put that in perspective. Um, you know, broadcasting a television show, sending and receiving a signal as we understand it or whatever case may be, transforms in this understanding of Tesla's understanding of what have you as more of on the side of sympathetic resonance. You see what I'm saying? Similar to what Keely was talking about, similar to I don't know, that what we relegate to synchronicity and serendipity sometimes in our own lives or whatever case may be. You see what I'm saying? Um, yeah, but that's pretty much what I have for today. I appreciate y'all for tuning in. Peace and blessings, man. Just catch y'all on the next one.